Okay, so let me start. Okay, so I'll be giving a 15-minute talk on what object automation does. Okay, so my name is Madan. I'm a tech lead in object automation system solutions private limited. So our head office is in California. So our CEO is Mr. Ganesan Narayanasamy. He has come from all the way from California. He's in the first floor meeting a professor Meena. So this is our development center. So this is the place where we teach students. So people come here, like Indian students. So most of the students they come during March and May and June for internship. So it is mandatory as per university. So they do internship on AI, chip design, cyber security, all these things. Whatever the recent topics, highlighted topics, they do internship, 15 day, 30 day. So okay, let me move the slide. So three things we do. So three things we do. I want to see you. Okay. Okay, three things we do: research, solution development, and center of excellence. So research you might be knowing. So you have many organizations, your college also there will be a R&D people, MC students, PhD. They are all research. Then solution development. So chip design project, AI project. Sorry. These are all solution development. Next is center of excellence. Center of excellence is nothing but so a lot of university and colleges they approach us. We have connection with various vendors. Like we have Microsoft partners, HP, Dell. So what as a like for example chip design. There are chip you need to have chip. Similar to that, for to set up a lab, we need a lot of hardware and software. Sorry. So we procure them. So we procure these things from a vendor at the cheap prices and we sell to various university and colleges. There we establish a center of excellence. So I can quote some few, like in Tanjavur, Shastra University, in Mysore, National Institute of Engineering. So these are all some of the universities and colleges. We are center of excellence. So next thing is, yeah. So Open Power Foundation. Anybody any idea what is Open Power Foundation? So you are a chip design workshop, okay, 30 hours workshop. So I'll just give you a brief introduction about what is Open Power Foundation. Open is nothing but open source. Power is nothing but the collection of processors. So this is from IBM. So IBM it has a non-profit organization called Open Power. So through Open you can as students, individuals, organizations, they can become a member of Open Power Foundation. So what is the benefit of becoming a member? So you get open source tools. So for example, you get access to open hardware tools. So like Vivaldo, all the lot of few things are there. Are some open source tools. Okay. So instead of paid tools like Synapses, those are costly. So instead of going for costly tools, which companies cannot, which institutions cannot afford, what you can do, you can become a member of Open Power Foundation. Then using this Open Power membership, you can access to these tools. So open hardware designs, firmware tools. You also become a member of global community. So now in these days, networking is very important. So if you become a member of this open source foundation, you are part of a global community. So you can interact with people from around the world. Okay, you can give your opinion, you can ask your doubts, they will be able to solve the doubts. So you can like all these things you can do with the help of being a member of Open Power Foundation. So these three things, what are the three important things you can do? One is build custom hardware. So you can build custom hardware system with Open ISA. So ISA is nothing but instruction set architecture. So it is from Open Power Foundation. The hashtag is open. Next is using this ISA, you can design custom CPUs, SoCs, systems on chips, then entire hardware platforms. So these things you can do with the help of becoming a member of Open Power Foundation. So these two slides is very useful for people from ECE and ECS. So you did a workshop on chip design. So this is very useful for you. So go through this. You take time. I'm just giving you a highlight on these two pages, slides. You can have a look at it. So you do projects like microwatt. So using this Open Power Foundation, if you become a member, you can do projects like microwatt. It is an open source software. Using this, you can do projects. So these are the 5 things we do mainly. So if you can see here, as I told you, center of excellence is one of the things. So research solution development, establishing centers of excellence. So we do this for various universities and colleges. So this is the fifth one, and we regularly conduct faculty development programs. So there is a bridge between there's a gap between the industry needs and the academia. So to fulfill this gap, we can regularly conduct FTPs, faculty development programs for faculty members, like for example AI, Gen AI, cloud computing, cyber security. These are the relevant recent trending things. Next, we do a lot of training programs. So that recently, Jagan and Kirmanadi, they came to your college. So this class, they conducted a 5-day, 30 hours course. So like this, we go to various colleges and universities, regularly conduct workshops like chip design, Gen AI, cloud computing. So the cloud is nothing but everything now, everything is being moved to the cloud. Then data visualization. So all these recent topics we cover using this training program. And also we have tie up with various universities in US and Europe. So there is a university in New York, New Jersey Institute of Technology. So after your undergraduation, you people who prefer to go for post graduation higher studies to UK and US. So we provide them like what type of visa you need to have, how much money you need to have. So what is the test you have to take. So all these things, what are the prerequisites? We give you information. All this information we provide to the students. Okay. So as I said in the very first slide, these are the three things we do: onshore, offshore, development. So we have our resource persons here in Chennai, in California, and around the world. So technology enablement and center of excellence. So these are some of the technical courses we provide. So we do in person or on campus. So we go to various like they recently studied on campus, that is on campus. So people also come here. We do in person, online, offline. We do all types of mode. The technical courses. Then we provide internship. So as per announced now, so most of the colleges, engineering students especially, in the third year and fourth year, they have to fulfill the requirement for as per announced regulation. So they do a 15-day, 10-day internship on chip design, AI, Gen AI, cloud computing, cyber security. So these are the internships they do. Right? Then we regularly conduct global AI and chip design conference. So last in August in SRM Ramapuram, we conducted a global AI conference. So in every year in India, in other states of Tamil Nadu, other parts districts of Tamil Nadu, in other states of India, we conduct AI and global AI and chip design conference. Then short time workshops. So workshops, it ranges from 1 to 5 days. So we have a 1 day to maximum of 5 days of workshop. So these are the three things we onshore, offshore. These are three things we do: AI resources, HPC, high performance computing resources, then chip design verification. So these are the three things we do: onshore and offshore development. So AI and chip design solution, AI based solution and chip design solution. These are the two research solutions we provide. So these are our international key collaborators. Like for example, we tie up with University of Oregon. So people are regularly there taking our course Gen AI. So we give them access to University of Oregon server. So with CPU and GPU, with CPU and desktop, we may not be able to process the data. Now we have large amounts of data to store them. We need cloud and a server access. So people who join our courses Gen AI and also we provide them access to University of Oregon. We are tied up with University of Oregon where we give them a student ID. They can access the University of Oregon server. Then University of Wisconsin. So a lot of CSC programs we are doing with the University of Wisconsin. These are some of our international key collaborators. Okay, so you must be knowing most of the colleges, universities. So NA is one of the oldest university. It's in Mysore, National Institute of Engineering, where we have set up a center of excellence. Then VIT, Shastra, SRM, so PSNA, Sai College, VIT. So you and I can also be coming next year. So yeah, these are the things we provided until now. So some of the things are in Tamil Nadu, some of the things in other parts of India. Like New Horizon, it is in Bengaluru, NI in Mysore. Then we have JNTU, Jawaharlal Nehru Technology University, Anantapur. So we also cater to various universities, colleges in other parts of India. So this is an IBM career education program. So IBM is a very big company. They provide a CEP, career education program. So it is a joint degree. So you get a B degree. So once you do this course, so So this has to be done from the first year, first semester. It is an 8 semester course. So currently we are doing with DMA College of Engineering and other colleges. So like first semester they'll be like we're doing an AI course, big data. So first semester they'll be learning Python. Second semester they'll be learning Java, front end on like few things on big data. So it is every semester they have to take a course. They have to take a certification. So after the at the end of the 8th semester, they'll be giving a degree from IBM at the respective college. It's a dual degree. It's a joint degree. So these are some of the specializations. Currently, we are doing big data analytics. So cloud, you can also, for many people, I think so you are from third year. So people who are in the first year, they can first year, second year, they can start, they can do this course, IBM Career Education Program. It's an 8 semester course. You will be getting a dual degree from IBM. I'll just go through this. So this is the interface area. So everything, so unison organ, we are giving access to them. We have GPUs. So now everything is of CPU, everything is graphical processing units. So when you want to store large amounts of data, process large amounts of data for Gen and all, you need to create algorithms which requires large computing power. So these are our special courses. So we provide, so we are Microsoft partner. We provide courses on Microsoft Azure. Then GenAI, Enterprise AI, chip design. So we recently conducted a 30-day chip design course. Then science course. So these are the software we use, like IBM apps and we use for AI. So he is Mr. Ganesan Narayanasamy, our CEO. So he stays in California. So Object Automation Software Solutions, System Solutions CEO. Okay, thank you very much. So you have any questions? So as part of industry visit, I gave a brief profile about what our company does. So going forward, we'll be having a few topics on chip design and Gen AI. Thank you very much. So the broadcast works well?
Yes, sir.
Okay, cool. Welcome you all. Which year you are from? Which year? Okay. Third year ECE or ECE?
Another batch is in Bronco. They are from electronics and computer.
Okay.
The students are from electronics and communication.
Oh, that's the one actually. The electronics and communication is a very popular course right now. Worldwide, a lot of people looking into it. And you are in the right spot right now. The ECE candidates are all very important. For last 10 years, there are a lot of challenges, but next 10 years, every country wants to develop their own chip. You know what is chip? Madan talked about the chip design solution, and we will be talking more about chip. Without chip, we cannot do anything. Everything is made using chip only. All the electronic equipments, computers, and even this camera, and even the phone. And how many phones are there in this lab right now? Maybe 30 phones. All the things need chip. What is this? I'm holding a chip for you. This is a chip we designed as in collaboration with IBM and Open Power Foundation. That's where I belong to right now. I lead the foundation internationally for 200 countries, and we are working with multiple countries to build a chip like this. Photo. Do you want to understand more about the chip? What is chip and how to develop chip and all this stuff? Would you be interested? Any, you guys have to be more interactive. I want you to talk about it also. Even local language is also fine. If you want to ask questions, so that it will be very useful for you. One day you'll be holding this kind of chip in some countries. Because India is a mass technology resource producer. Because we have a lot of people who have got good skilled people who can go and work with countries and build chips, technologies and everything. Right? I know that at third year you may think that hey, this person talks about
chip development and all. But this is the stage, this is the age you need to work on. You need to start incorporating, some of the industry stuff, right now, not after 10 years or after 15 years. That's why I encourage personally a lot of students to go and learn something new on the technology, whatever we're talking about here. Okay?
Don't have any questions.
Any? What is it? I don't know.
Questions.
Yeah, that's what. Yeah. Any questions? And this is a AI chip. It's not just a chip. AI chip, artificial intelligence. Do you guys know what is artificial intelligence? Hmm? Someone can just stand up and talk, or maybe sitting also you can talk. What is artificial intelligence? What is intelligence first? What is smartness? When you go and solve a problem in a different way, always you may be applying the smartness, right? And artificially you can apply that too. How? Basically is a kind of intelligence where you basically gather it from multiple sources and create a kind of a stack with set of events and activities and everything, and that's how we all put together. And we call it, like, right now, today's stage, uh, you know like a chat GPT, right? What is chat GPT? Chat GPT, anyone is using chat GPT in this room, guys? Hmm? Is it, are you guys hesitating to say, or you do not know chat GPT?
They know.
Hmm?
They know they're using.
What does it do, chat GPT? Hmm? What does it do? Hmm? Very good. Thank you. I think I need a person like this, to communicate actually first. So the communication is very important. Now, whatever question I'm asking, you communicate it, and that's what the Chat GPT also does. But artificially, it does. That's where how it collectively collected the information, prior to you are asking the question, and then it will answer your question accordingly. That's how it transformed. So like that, even if I host a program here for a day, you can collect all the information and store it into a storage, and then later on you can make the storage to answer some of the questions from the storage. That will tell you, right? Because so many things I would have mentioned in last 5 minutes and last 30 minutes, whatever Madan presented, and I'm talking, and my team, my colleagues, will be talking. Everything you can collectively put it in one storage and ask the computer to answer the questions from that set of instructions, whatever we insisted, included, whatever, right? So like this, you can also put your own chat GPT kind of information. I mean, a tool for you to, like, basically you can start training, and later on you can ask the system to answer your questions. And without chip, can you do that? Why? Why? Without chip, can you do that? He said no. That's fine, but I'm not going to pull your leg. But anyway, just why? Why? Software is actually the one, the AI. A lot of AI, is basically software. Software cannot do anything without hardware. We need hardware to process your data. Whatever data. Data is even VoIP, the voice over IP, like whatever voice message. That is also data. Data is basically, if you keep it there, it will be like a kind of, the podium, just standing there. It will not do anything. It will not move on its own. But with hardware, with kind of a mechanism, IoT and all the stuff, if you implement, this can be, we can transfer this, from one place to another place automatically, right? That's how the cars are all made right now. Do you think of a car moving on without a driver? Do you know that is happening? Anybody knows about it? It's all computer only. It's all AI only. It's all hardware. This kind of a chip, inside. Anybody knows a car on its own driving? No computer. I mean, no driver inside the car. You don't need a driver, going forward. Do you know that? What is the car name? Hmm? Tesla. There is another car already on the road driving. Tesla is not on its own driving. It's basically kind of 80 percentage. It will drive on its own, but 20%. Huh? Hmm? No, that is also another. I mean, these are all like I would say electric car, but there are a lot of automation done. But you need a driver for the car. But there is a car already driving without a driver. You guys should know about it. Hmm? Mahendra. No, a car like on the road, a car goes without a driver, and it can take you to the Wales University from here. If you get the car here, who should think about it? Like the person, if he decides, if he wants to make a plan like this for India, he can make it happen. Who is that? Hmm? What? Guys, you should know about it actually. Google. Google cars are all like without a driver it's driving. So and Sundar Pichai, if he thinks he wants to make a car for India like that, that can happen too. Here. How did you come to our office from Wales University? Without a driver, a bus also can go. It's all automated completely. Just Google around, Google car, Waymo. It has been running. 500,000 cars are there already in US, in California, in all the big cities in US, Phoenix, Florida, everywhere I saw the cars too, and I also personally use the car. Taxi, like Uber, you can call Waymo over the app, and it will come to your parking lot, and it will pick you up, and then you can reach the destination, and nobody is going to drive. It's basically the computer is going to drive and take you there. Waymo car from Google, and that is already popular these days, and it's all artificial intelligence, and then the chip driven. You think about it, how many chips in the future we need to make the car to go all around the world, right? These are all the technology we are heading to, and definitely the computer science, AI, and ECE. These are all the courses will help you to get into the level. Okay, so this here one you guys know only some of the things the Tesla and all this stuff. That's good, but go to the level like where how they Waymo they implement it, how they deploy it. This has been running for last 2 years in US. Waymo cars from Google. Okay, so that level you can also think about it, and you can move on. And Sundar Pichai, who is he? He's one of the Indians who came from, who went from here, from Chennai to California, right? And he's the one making it happen. Okay, so think about that and see what you can do as part of that the Google innovation, or the Tesla innovation, or the IBM, the company which has been there for last 100 years with lots of computer technologies, along with the quantum computing. You guys know about quantum, right? The quantum is coming up. The new, in next 10 years, all the existing laptops, desktops, and all those stuff will be replaced by quantum kind of the supercomputers. and it will do a lot of activities, using that. So that also you will see in your career, definitely in next 10 to 20 years, there will be so many changes, will happen in the technology. That's what you're going to see. Okay. So next 1 hour, right? 45 minutes. You'll be learning about a lot of things, and then be proactive on that and observe and see what you can do, what you can contribute as part of the technology, what we are going to share. Okay, and with that, definitely you can step up, and do things for 200 plus countries in the world, not just one within India or within the state, whatever we are in. But and also one more thing, Tamil Nadu has got all the features, whatever we have in California and we have in New York. All kinds of the features are there in Tamil Nadu also. If I want to spend more time on that, then you will be losing my technical teams, the sharing. But anyway, maybe if you are interested more, let me know. We'll have another seminar over the phone, over the Zoom meet or Google Meet. But in the meantime, right now, I'd like to invite Rahul. Come over. Rahul is going to be sharing, the AI, what we are trying to do, what are the AI things we are trying to do, right? And he has got some good content now he already built so many things which he is going to be sharing with you. Okay, guys. So stay tuned and get motivated to learn more and probably go develop things on your own. Okay. Thank you very much. Wish you all the best.
So yeah, good morning all. So like previously we were discussing about AI, right? So like what do you know about AI in general? So what AI does? So why do we use AI? And where do we use AI? So anyone can say something on that. So what is your idea and on where we are using AI? So what type of AI are we using now? So what is that? What type of AI is that? Is it open source? Can you build your own ChatGPT kind of thing? Can you train a model? Okay. So AI is of two types. Okay. So one is traditional AI. So where you might have heard about machine learning, deep learning, right? So these are like where we have a huge bunch of data. So from there, what we do is we train we have multiple algorithms in machine learning or deep learning. So for each algorithm, where we will be having a bunch of data, right? For example, if we are training a model to classify spam detection kind of a model, okay, using machine learning, okay. So what we do is we collect a bunch of data which are regarding to the spam detection, and we will be using like any machine learning algorithms like decision tree or support vector missions. Okay, and we train these data where it understands the patterns in the data, and at last it comes to a a trained model where it understands each data's pattern. At last we have a model called spam detection model. So whenever you get a email from you win a lottery, or like congratulations kind of thing, so these are the keywords which will be in the data sets. So using these data sets your model will be trained. Whenever you receive a mail with these keywords, your your model will detect them and classify them as spam or not. Okay, this is how machine learning will be using machine learning to train data and extracting a model. So similarly with deep learning, so with machine learning we handle only data of text. Okay, so but in when it comes to deep learning, we can use unstructured data. So unstructured data in the sense like audio, video, images. So these are these types of unstructured data, they can be handled only using algorithms of deep learning. So okay, so using deep learning, we can come up with a model of sentiment analysis or text generation or text summarization. So using the data, we can come up with a deep learning model. Okay, so from there, okay, so on 2017, Google came up with a white paper. So which is attention is all you need. Okay, so which is basically idea from like in deep learning algorithm, we have something called transformer architecture. So this transformer is what is powering the chat GPT. Okay, so Google came up with some idea like before this like LLM, ChatGPT kind of thing, LLM like before that add something called BERT model. So what it does is it is a bi-directional encoder. Okay, so what it does is it can understand your sentence from front to back, like forward to to the end. It can understand your sentence, and it can predict the next word, but it doesn't like classify the like the context of the whole sentence. It doesn't have the it cannot understand the whole sentence context. Okay, so that's when they came up with this idea of transformers. Okay, these transformers, they have the both encoder and a decoder. Okay, so this encoder is what helps you to understand the context of the whole sentence or a whole conversation. Okay, so the decoder part. Okay, so these decoder part, he helps you to predict the next word. Okay, what can be the outcome of the next a word in the next sentence. Okay, so these all things, they happen in the form of mathematics. Okay, all your words, they will be represented as in the form of numbers when it comes to machines. So that's why they can understand the systems can understand only numbers, right? So we need to convert them into numbers. All your words will be converted into numbers, and they are not just random numbers or something random. Each each number, they carries similar meaning. Like if we have what is gen AI, so what will be converted into point 2, like is will be converted into point 3, and gen AI will be converted into point 4. I'm saying it for an example. Okay, so this point 2, point 3, point 4, they carry the information which is related to your word. Okay, they will not be generated randomly. Okay, so for generating these numbers, we use something called embedding model. Okay, so this embedding model will help us to convert our word into a vector in the sense numerical representations. Okay, so all these will be represented as a transformer architecture. Okay, so that's what that's how you are using your LLMs like ChatGPT or Gemini or Claude and so on. Like all other models, they follow this LLM kind of architecture. Okay, so this is how your Gen AI applications are powered. Okay, so okay, so Sab was discussing about AI system where we can store a whole bunch of conversation into some storage, and after that we can make the AI to answer from those storage. So that is where that is how chatbot will be working. Okay, so these chatbot they work based on a concept called retrieval augmented generation. Okay, so RAG, like basically in short form, they will be known as RAG. RAG. Okay, so basically what happens is this retrieval augmented generation is of two parts. One is retrieval. Retrieval in the sense whatever the data you are stored in your storage, it will be retrieved when a user asks a question. Okay, so whatever the relevant information that is related to the user's query, they will be retrieved from the database and they will be sent to the AI, like your model, like LLM model. It can be either ChatGPT or any model if you prefer. Okay, so these model like based upon the retrieval, so these model will be processing your final outcome that will be displayed in your front in your display. Okay, so that is how this whole chatbot will be working. Okay, so out of that we created our own chatbot for our object automation website. Okay, so the goal was to build a smart AI powered chatbot to handle customer queries. So whoever they want to ask question based upon our course or our whatever, like what are the development kind of thing we do. We don't need a person specially handling those tasks. Okay, so to overcome that we created this chatbot. Okay, so after that like it helps to automate the customer service. Basically whenever you come to our website and ask us something about like the course or the solutions what we make or what are the services we provide, like email will be triggered and WhatsApp message will be triggered. Okay, so like whenever you make some queries to our chatbot, all those queries will be sent to the admin portal or the email. From this chatbot an email will be triggered and we can see whatever the conversation you are having, what are the queries you are sending. Okay, so all these information will be triggered through email and WhatsApp. Okay, so the technology what we use is RAG and we discussed about that. So for the front end, we gone with HTML, CSS, and JavaScript. So basically for like for our chat icon, so it will be when we come to our website part, I will show them it will be a chat icon on like at top, bottom of the page. So for creating those we have came up with the HTML, CSS, and JavaScript, and we use something called Ajax slash fetch. So it is a function which helps us to make asynchronous communication between front end and back end. So in the sense we which helps us to if you are entering your question in the front end, it should be processed in the back end, right? So which is going to help us is this Ajax fetch function. Okay, so that's why we came up with this Ajax fetch. So next we have the backend technologies. So our backend technologies, the whole text stack is of Fast API. So first with Fast API, it is a Python a framework for backend. So what it has is it has asynchronous server, so which basically helps us to when a user sends a query, it helps us to handle all the queries in the asynchronous way. Okay, so and next is retrieval augmented generation. So we already discussed about retrieval augmented generation, which is of retrieval and generation part. So it is a whole kind of technique where we so the pipeline will be looking like first we will gather the data which are needed to be stored in some storage for setting up the chatbot, like what are the questions it need to be answered, like like what is the like you will be having some purpose, right? So for the customers, like I should be answering this, or for the employees, it should answer to the company's policies. So likewise, it data depends upon the use case. Okay, so first step is ingestion, which is basically collecting your data and storing it in the in a storage. And next we do text pre-processing. Text pre-processing in the sense all your data, they will be in the form of PDF, or text document, where they can have punctuations or double quotations or commas, or in form of PDF they may have unwanted tags, so we need to remove them. Okay, so we need a clean text, so we do text pre-processing. Okay, so after all those text pre-processing, we move to a step called chunking. Chunking in the sense, we are going to break down a whole bunch of paragraph into part, two half, so that when it comes to processing all those information, it will be easier for the machine to understand them. When it is of full size paragraph, the machine will be finding difficulty to understand the whole context. But when it is half, paragraph is into one and two halves, so it will be more easier for the machine to understand the whole context of the paragraph. So that's why we do chunking. So after chunking, we what we do is convert those chunking into embeddings. Okay, so to convert the embeddings, we use the embedding model. Okay, so this embedding model will help us to convert our data into numbers. Okay, and these numbers. Okay, so when it comes to GenA applications, we don't use regular databases what we use in day-to-day tasks, like MySQL or PostgreSQL or MongoDB. We don't use any of this when it comes to GenA applications. We use something of a specialized database called vector database. Okay, what this vector database do is, these vector database they have something of in all they like in normal databases, everything will be represented in the form of tables, and in these vector databases they will be represented in the form of dimensions. Okay, dimensions in the sense, it depends upon the the embedding model what we have. So like we cannot visualize a dimension of 786 or 384. So in real life we can imagine up to like 3 dimensions only. Okay, so all these embedded, when they are converted, they will be stored in the vector storage, vector database. Okay, so these vectors database, they have something called approximate nearest search neighbor. Okay, so what it it fasters the searching process, where it can search through a millions of billions of documents in 1 second. Okay, so that's why this vector database are used in GenA applications. And after storing them in a vector database, yeah, so then we set up the LLM configuration. So that is what going to help you to get you the final answer. Okay, so that is how the whole pipeline is going to be. First part is going to be of the retrieval, another second part is going to be of generation. Okay, so this is of RAG is okay. So next is sentence transformer. So the sentence transformer, it is a library which is going to help us to get the the embedding model. So next is FIAS. So I was talking about the vector database, right? So the one of our kind is FIAS. So FIAS, it is a Facebook AI similarity search. So which is basically built by Meta. So this FIAS is a vector database library which will be helping us to store the all our embeddings. And open router. Okay, So we need a model to generate all these final answer, right? So most of the providers they don't provide the model in free of cost. Okay, so these open router, okay, they are part of OpenAI, which is basically company which owns the ChatGPT. Okay, what they do is they give you a LLM model through a API key, but they are not totally free. They can be like a 50 tokens per day is free. Okay, so like after that you need to pay for them, like in terms of credits. Okay, so if you want to experiment or prototype anything using GenAI, you can go to this open router website and you can get your own API key through which you can access the model. So next is PDF Plumber. So PDF Plumber and Beautiful Soap. So we these are the libraries which is going to help us to perform extraction and text cleaning. So the front end user interaction. So as I already mentioned, we'll be having a floating icon in our website. So if when we click them, that chat window will be opening, and you can enter your query, and based upon that, all the the query will be sent from the front end to the back end, and all the processing will be happening in the back end, and you will be in the front end your answer will be generated. Yeah, so you can see the whole process, how the chatbot will be working. As I mentioned, we are loading and extracting the data, and text is getting some, and they are going to the embedding model, and they are getting stored in the vector database. And when the user sends a query, they will be performing a similarity search in the vector database, and they will be top relevant chunks will be sent to the LLM model, and the LLM model will be sending you the final output to the front UI. Okay, so this is the whole end-to-end flow of the chatbot what we made. Yeah, so this is how it basically will be looking when you come to our website and click the floating chat icon. So the chat window will be opening, and you can ask questions anything related only to our website. Okay, so that's how these chatbots will be working. So these RAG based chatbots, they can be answering only to the data what you are provided in the storage. Okay, so they cannot they will not be designed to access something out of the box, out of the website, or something out of the company. Okay, so that is how these RAG chatbots will be made. So any doubts over here? So recently we also made a interview bot. Okay, so what this interview bot will be doing is, so basically when you enter your all your informations like your name, email address, what role you are applying for, and what is your experience. So you need to upload a photo and a resume and your cover letter. So what happens now is, so your resume will be sent to the AI, like the Gen AI. Okay, so first round is going to be of aptitude. So in the first round, the LLM will be generating you the answers, questions. I've set it up 30 10 aptitude questions, 10 logical questions, and 10 communication questions. So these all 30 questions will be generated only by the LLM model which I've set it up. Okay, so it will be generating you the questions, and it will be displayed in the front end. Okay, so you will be monitored to your camera. Like if your face is available, it will be showing your face is available. If multiple faces are detected, multiple faces will be shown. Or if you're not available over there, your face no face is detected will be shown. And you cannot switch between tabs, or you cannot do a copy paste on all these validations are implemented. Okay, so when 30 questions are generated, they will be displayed, and you will be having 45 minutes to answer them. Okay, so you will be answering all the 30 questions, right? The 30 questions will be generated, evaluated by the LLM itself. Okay, at the last. So for the second round, what it does is, like whatever the resume you are uploaded, it will generate you three questions based upon the your resume, whatever you mentioned about your project, your certifications, your experience, or the tools you are familiar with. So we'll be generating three questions. And okay, so when you move to the next round, okay, so you will be asked a question of based upon the job role you are applying for. Okay, so let's say you're applying something for chip design, and it will come up with some questions related to your domain, like chip design domain. Okay, so after that, at last we have set it up a coding round. So based upon the position you are not applying, so two questions will be generated by the LLM, and they will be displayed, and you should answer them. At last, all this your whatever you answered, we will be using the LLM to evaluate them. So at the end, all the process will be done automated using this LLM only. So this is the this is another project we have done, which is a interview bot. Okay, so so do you have any doubts in this interview bot? So do you have any other doubts regarding AI or Gen AI? So currently, no, we are marching towards agentic AI, where a single agent can automate all your tasks. We don't even need a human intervention in the middle. Like we don't need something someone seated to be in front of a computer to code. All these things can be done using a single prompt. Using you might have heard of the Claude code kind of agent, where it can you don't need to be in front of your computer all the time, where you can access all your terminal in your phone itself, where it basically codes all your applications with a single prompt. Okay, so this is where we are in the era of AI, like agent AI. Okay, so any doubts? So, you guys have any ideas like how we can implement Gen AI with FPGA board or anything? Implement AI with FPGA board. So yeah, okay. So if you don't have any doubts, let me move on, and we will continue with the chip design talk. Yeah, thank you all.
Okay, myself second. Uh, uh, Previous week, I basically I built the AI wearable devices, which is basically kind of monitoring system. kind of portable thing. Okay. Previously, you guys, I mean, the previous generation, we have monitoring watch that can sense your heart rate and walking steps. You guys know about, right? That kind of watch. Anyone now wearing that kind of watch? Smartwatch. Yeah, you guys used, right? Yeah, that's a kind of the previous generation watch. Nowadays, just we integrate kind of AI things and just monitor the readings. I mean, just store the readings from cloud. These are the features I actually added in my project. Basically, these are the content of agenda which is I'm going to present today. The basic introduction of AI wearable devices and problem statement and the objective of my project and overview of this entire set and what are the things I use in this project. Kind of I used one board. This is the board I use and I used C language and Rolama model which is kind of AI and I used a set of sensors to collect the readings from human body. These are the things, and basically my project is monitor the readings in your, I mean readings kind of things, your heart rate and skin scent. I mean skin moisturize and brain waves. These are the things which is going to take the read. Not short time. It monitors the 24/7 and it collects the data and stores in TeamSpeak. It is a kind of open source one. You guys can also use, and it will show them. It will use the output. And I had actually used the features called if you guys have any I mean any abnormal readings detect from your pulse or brain waves, it will send the notification to your I mean uh, notification to your Telegram or I create a bot from Telegram. It will send the notification to Telegram. Okay? These are the features are basically built in this, and this is the basically introduction of AI wearable devices. Basically, it is a health detection parameter wearable devices, and I used here the core components is Vega board. This is the Vega board, which is completely built in India. This board is basically built in CDAC. You guys know about, right? CDAC. CDAC is basically R&D organization, which is in India. Okay, it is an central government organization one. Okay, and I also use the sensors to take the information from human body, and I use the ThinkSpeak. It is a kind of cloud which is used to store the data from which is taken from us. The data is to be going to store in ThinkSpeak, and I use the Telegram bot, which is basically send the notification. Alert notification. And the key benefits I mentioned here, the 24/7 monitoring the readings and uh, which is in the real time and AI powered, and I have already the problem statement. Before this, before my project, it is a you are watching the previous generation watch. It is basically a lack of real-time monitoring. It will just when you guys going to take the readings from just you guys are going to readings from just click and you will see the particular the particular minute reading only, right? It will show the current reading only. It is not monitoring the 24/7 reading. Okay. In my project, just I implemented the thing, and if you guys get the monitoring also, it is if you have any difficulties in your health, it is not send the notification to authentication person, which means it sends the notification to your parents. It not send the notification to your caretaker. It is not a possible. The previous generation was in this prototype. I implemented this kind of things and high cost of the high cost monitoring is if you going to keep any caretaker in your home or to personal assistant to take the care, it takes lot of cost, right? You want to pay the caretaker I mean thousands of it takes thousands of cost, right? If you use my prototype, it will reduce the entire cost. The board is basically around 1,500 only, and if you guys want to spend some money in some sensors only, these are the almost cost. You can build this project around 4,000. Okay, this is the maximum cost, 4,000, and these are the problem statement. I'm going to overcome this, and these are the sensors I just used currently, and it is not a final one. We can implement more sensors. Basically, I used here sensor is heart rate and SpO2 and temperature sensor. These are three sensors only I use. I mean, we can use different sensors also to monitor the different readings which is in our body. This is the system overview. Before that, I want to say, I mean, build a prototype only. It is not a kind of wearable devices right now. This prototype we can implement in ICU. They monitor your readings, right? It is a lakhs of cost if you stay in hospital in ICU ward for the 30 days. If you want to pay lakhs of cost in the hospital, right? If you just build this kind of prototype and just keep the prototype near to your patient, and it will monitor the entire readings, and it will send the alert notification if any abnormal situation is occur. Just it will send the abnormal notification. It will send the notification to caretaker, and you can send the multiple notification, alert notification to multiple persons. Okay, these are the current thing which is in my project. And
Can you have used the processor? No? Is there any purpose using this particular processor, or we can use any other processor?
yeah, we can use different processors. Just the processor is just process the data only. We can use different processor. Just I'm using the processor called Vega V3. Okay, this is the processor I currently use in my processor. Basically the system board use the sensors and the Vega board. The sensor is going to collect the readings from your body and just give to the Vega board. The Vega board basically process the data and it will send to the your system. That system I used here the model kind of Olama. Just basically it will process your data and give the proper reading. If you collect 4 different readings, right? Some of the person have basically they have basically the person is a sugar patient. The sugar is basically higher only. Okay, this sometimes they take some many sugar content, it will rise. That is not a issue. Okay, if you process the entire data from AI model, it will give the accurate result. If the person is normal condition or if the person is abnormal condition, like that. Just and the data is going to share 2 different things. One is ThinkSpeak and Telegram bot. Just I'll show the ThinkSpeak. It is the ThinkSpeak interface. This interface you can open your system, system web page and also open your mobile phone also. Just you currently I use my email ID. Just create this ThinkSpeak. Just you can forward this URL to your mobile phone. Use the same mail ID. You can monitor this entire readings in your phone. Okay, just you can see here I use 2 different sensors only. One is ECG and one is a heart rate. We can implement multiple sensors also. Just you can see I just give one of the reading. This reading is taken from Thursday, March 19, 2026, and the time is 3. Okay, just you can see this. And these are the entire overflow. Just entire flow of my project. Just the upcoming things is basically in this project I use C language and Python for AI ML development, and I use the ThinkSpeak API and the Telegram for send the notification, alert notification. These are the software tools I use in my project, and this working methodology, the data data acquisition and signal processing and AI analysis and cloud upload and alert. These are the five things and the five things in my working methodology in my project. And these are the things I already explained. Data monitoring by using ThinkSpeak. This is the interface, the ThinkSpeak. And the alert system for AI bot. And this is the final result of my output. And yeah, this is my alert notification, which is shared. The alert notification to Telegram bot. Just you can see this is the alert notification when you are in the abnormal condition. Just my prototype is just share the alert notification to your bot. For this bot, just you can create your own bot. Just in that bot, just you can generate ID and API. Just that two things just you can implement in the thing. This is my script, Python script. Basically, in the script, just you can see this is the ThinkSpeak API, which is taken by here ThinkSpeak. Just you can see here, API key is listed. Here you guys have the API key. Just you can copy and paste in the script, and here you can bot token. This is from Telegram bot. This is the ID from Telegram. This is the basically the project. If you build this kind of project, means it will basically helpful for your placements, and you can also if you guys come up with any innovative ideas, you can patent your entire thing, and you can manufacture the prototype by using your own. And basically in my project is very minimal amount of task only I built. Just we can acquire kind of sensors which reading is going to monitor the human body, and just if you want to buy the FPGA board or a kind of board which is you also use, which is the board you are using in your college. Basically this is the board. This is the board. We have one chip here. This is the processor called Iris P3, and you guys have the multiple GPIO pins, and these are the things this board have. This is minimal requirement. This board can also connect the Wi-Fi module. By using Wi-Fi module, you can transfer the data, and throughout the internet also we can transfer the data. There is two different ways to transfer the data from this board to throughout the cloud. If you build this prototype, you can monitor the readings from wherever you are in the world throughout the internet. Okay.
What about the storage space?
Storage space. If you use different Azure or something, you can pay for the storage space. You can monitor the. I already tried this. I stored the 2 to 3 days readings. I don't know the exact storage space. It can monitor the reading and store the reading 2 to 3 days. This fine. Is there any doubt from my project? Yeah. Can you speak louder?
If there is no internet connection, then how do I get the alerts? They will call.
Yeah, you need. Internet is very must. Without internet, we won't transfer the data. Any doubt? The flow, yeah.
Why are you using various groups instead of other processor?
Yeah, basically it is like a task efficiency because we are going to transfer the data only, not a different processing. Just we gather the information from sensor and just process the data. Just process the information and the information just transfer to AI model. The AI model only doing the entire thing. The board is only gather the information from sensor and move to my model. So if you need additional features, just you go to different boards. Here, basically this board can contain the Wi-Fi module, and this is enough for transfer the data. And some other doubts. Okay, thank you.
Good morning, everyone. So, like, I'm just going to show you the demo of like what we had. I already explained you in the class, like when we take session about the microwatt. Did you all worked on like microwatt? Did anybody work? Are you all aware of what is microwatt? So basically, the microwatt is a open source CPU processor. Okay, it is built on VSTL. So like you can get the code available in the GitHub. It is fully open source. So using that processor, like you can create your own processor or like your own chip. Okay, so we have a detailed step like how we can move the code like from the code to the actual chip, like how we can proceed, like the steps that have been already been there inside the GitHub. Like if you search for the microwatt, like you can see. So the microwatt is built on specific architecture called the Power ISA, which is developed by the IBM. Like in the early stage, while in the starting of the making the chip, like the Apple and IBM were collaborated and they had designed the chip. So those adults were made under the Power ISA architecture. So right now you can see all the things like they had separate chips for it. Okay, so this is like the previous like this Power ISA is basically on the uh, risk architecture. Now currently we have moved into the risk file. Okay, so basically you can get the code of the microwatt, like you can go through, like you can because that has an capable to flash that code into the FPGA board. So like you can program it into the FPGA board, and that microwatt, that processor is capable of putting a Linux into this. So you can put a Linux, the OS like Linux into the processor, and you can work that microwatt as a complete system, like how we daily use. Okay, so this is the FPGA board like that we are using. This is like RTK700 board. Like while we are working, like we had gone through this FPGA board. So we just first randomly use some ports like AND or add multiplexer, that like that some codes into this. Then if you remember, like we had add constraint files, right, to control. So like in the constraint file, we had given some switches to control, right? So here you can see some like four switches and like four buttons. Like we can give them as an input, and like we can, after we program it, like you can just verify it with this inputs. Then we have here LEDs, like so that you can to get the output, like to view, like you can use this. So that is like for some basic RTL program, like we had seen. Right now, just I had coded the microwatt into this. I had converted the microwatt processor code into the bit file, that is specifically for the FPGA board. So what we need to do, we have already a hardware description language, the code that has been written, so that we have to convert it into the machine learning understanding code, like for the bit code. So if we while converting the bit file, like we have a certain process like synthesis implementation, like that we have in the file bit stream. So in this process, like it will convert your actual code into the board compatibility as a bit stream. Then after that, we will flash it. So you have an US B type code, like then we can connect and we can program it. So once we program this, then this board will work as a processor. Like so, right now I have programmed the microwatt. So right now here we have a microwatt processor that has been running inside this FPGA board. This is an FPGA board, okay. And we can, as I already said, like we can boot a Linux into this. So we already had created the image. So I already shared the file. Just you can go through it. So we already built the Linux file specifically for this process, because like we have Linux is capable for different process. So like we can build our own Linux based on like what are the configuration we need, so that this board can adapt. So after we build the image, like the OS, like we are putting that OS into this, like in the inside this processor. So once after booting this, like I already done this, so like I will just show you how it works. Yeah, right now I just connected with this from the my USB port to this board. I'll just run this because already we had flash, we had programmed it inside. Since it's already programmed, we don't need to reprogram it. Only if we had made any changes, we can reprogram it. So that is the use of this FPGA board. And another one thing, like you can see, I had also connected the SD card here, because like for the storage purpose, since this FPGA board has a minimal storage, like around 15 MB, I think, like it can store. So because right now we are planning to run more A programs into the Linux. So what will happen is, like if for that I need to add some more configuration to the Linux, like Python or by some libraries we have to add. So if I added the Linux, the OS size will get bigger. If I try to flash it, I will get the memory size overflow error. I can't get flashed into this FPGA board. So to increase the storage, I just added the SD cards. Okay, here. So it is like kind of a 64 GB. So using this, I had increased my storage. So right now, I just add my voice image into the SD card. So while booting it, it will try to get the image from the SD card and it will try to boot so that I can get the memory overflow error. Right now, just you can log into this. You all can see right at the bottom. So to enable these features, like you have to go into the build root. So that only will help you to create the Linux for the what are the configurations we need. So we can go into the build root menu config, and then we have to add this SD card stuff. Like from where you have to move that details you have to give, and additional features like Python and libraries, like what you have to we need inside this OS. Like we can enable it inside the features, and you can build the image from there. Uh, So right now we already had a program, that a program that I had moved inside, I had run inside this Linux. Like you can see, for like it is to predict for the house price. Like now I had the Python code and the model that I had run here. So here let me ask for the house area, square feet, bedroom, and the total age of the house. Then it has predicted the total the price of the house. Okay, so basically the sales is to run some AI programs into the Linux. That's what we have developed. So right now you are seeing the Linux that is been running inside this APG board. That's what we have developed. So using this, like you can run more AI features, AI programs into this board. So like that, for additionally, if you want to add more, right now, like this is works for the minimal section. So if you want to go with the more advanced features like the chatbot, like what they Rahul has shown, if you want to build it inside this Linux, so we have to add some more instruction that we have to update the microword code. Like if you all come across the instruction like called VSX, vector scalar extension like this, we all know. So for example, if I want to like add some more things like in the age, like I have to add this type of instruction like VSS VMX. Right now inside this microword, we didn't have this VSS instruction. So we are currently working on like adding the VSS instructions into this microword. So once we added the features into this microword, like we can get in additionally more, we can add more real model, actual model into this Linux. Okay, so that's what like you can all build from this microword, like this open source. You just go through that. You can make not like this. So what you want? So if you want a small processor also, like from there, like you can get and you can make your own processor based on your need. It may vary. So for us, like for the additional AI features, like we are trying to add some more instructions, like adding and increasing its features. Okay. Do you have any doubt in this, like? Like what other stuff? Open road. Do you have any doubt in it? Did you all try that the physical design RTL to the just flow? Like you get the movie idea, right? So basically, we had already run the microwatt as I told. So the same microwatt as we had saved out with the 130 nanometer already. Okay, using that open road tool only. So the open road is also efficient. Like you can generate, you can take out a real chip out of it. So just get used to that tool. Since it is an open source, like you can it is free. Like you can get access to the tools. Okay. You have any doubt?